the basic aim of this course is to enlighten you with the fundamental and basic raw idea behind locus of point. तो चलो हम start करते हैं. तो before we go and see what formally locus is, we'll try to be completely informal. So fundamentally speaking, locus is your location of points under some guardianship, right? तो locus क्या है? Locus is location of points under some guardianship, under some restrictions. For example, suppose if I give you a guardianship that we have a fixed point A, and now Golu has to move in such a way so that his distance from this fixed point remains constant, and let's say that distance is 1 meter. तो अब गोलू कैसे मूव करेगा, कैसे चक्कर लगाएगा such that his distance is fixed from this fixed point? So of course it will be on a circle. That your common sense tells, right? So this curve, the path traced by Golu is known as locus of Golu. So basically Golu का locus क्या हुआ? Golu का locations depending upon different positions that Golu can attain is the locus or is the path which is traced by Golu, right? So this is basically what Golu is tracing the path, and we call it formally it's a circle. Now what if we have two fixed points? Let's say we have point A and point B. Now suppose Golu wants to move such that the distance of Golu is fixed from both of these points. So since Golu distance is fixed from both of the points, so Golu should be equidistant from this, right? So these two distances will be equal. So can you think of a location? Of course, yeah. When you are completely midway between point A and B, right? We can have even Golu happy here, and so on and so forth. So basically, the path traced by Golu is perpendicular bisector, right? Perpendicular. Can you think of 3 points? Let's say point A, point B, and point C. So now where Golu should be so that is at equal distance from all the 3 points. That's not a tough guess. It will be somewhere here, right? Somewhere here, so that these distances are equal. So is this a unique location, or can there be many answers for this? Is it a unique location? Yes or no? Let's investigate. Let's say if Golu has to be at the equal distance from A and B, then he can be anywhere on this perpendicular bisector, right? At the same time, Golu has to maintain equal distance from A and C also. So he must be along this line, the perpendicular bisector, right? So now we know if Golu is here, then his distance from A and B is equal, right? And if Golu is along this line, so definitely at the point of intersection of these two bisectors, Golu is maintaining equal distance from both AB and AC. And hence it must be equal distance from B and C also. So the third perpendicular bisector must be congruent. And that's exciting because you can clearly see that Golu must be on the circumcenter of a circle passing through ABC. So these are the basic concepts. Okay. So this is all about pictures. Now the question is how mathematics is going to speak or see on behalf of these diagrams, because as a human we have got eyes, we have sense organs, so we know, and definitely fortunately I can hold a pencil and I can draw this diagram. How mathematics is going to create these emotions in terms of numbers and algebra. Okay, I'll give a very simple illustrations for a circle. So now we have already seen, like if let's say if we have a fixed point 0, 0, and we need a variable point Golu, so this can happily move anywhere in 2D. Okay, so Golu motion I am restricting to 2D because it depends whether it's 2D in 3D. Right now we are in planar motion. So now if Golu distance has to be always constant from this origin, so it has to move on a circle. It's like a rope is tied to a person and he has to maintain a similar distance. How mathematically these emotions will be captured. So let's say Golu position at any time is x comma y, and x y both is changing, right? Because it can be here, it can be here, but there is a guardianship which is tied to x and y. So the genetics of x and y, the relation between x and y will be invariant no matter where it is, because it must represent all these points, all these locations of Golu is having one common guardianship attached to this, that it has to maintain constant distance of 1 from center. So how that will get reflected into these dead numbers? So it's very obvious here, because distance from 0 0 to xy is x square plus y square under root, and that distance equals 1 by distance formula. And distance formula is nothing but Pythagoras theorem, right? And Pythagoras theorem is nothing but, it's a consequence of similarity. And similarity is nothing but zoom in and zoom out things, which most of you are doing it. So fundamentally everything comes out from your common sense, right? Anyway, so x square plus y square equals 1 is the equation. So this is how maths speak and see on behalf of our good pictures, nice cool pics, through the instrument called algebraic. That's why the coordinate geometry is the coordination of these dead numbers, algebraic expressions with beautiful pictures. So these dead algebraic structure is being alive, like it's drawing this beautiful picture through this equation. So when I tell x square plus y square once, algebraically 0 comma 1 satisfies this, minus 1 comma 0 satisfies this, 1 by root 2 comma 1 by root 2 satisfy this, and there are infinitely many solutions, right? So all that solutions you can see over this circle. So all these points belong to the circle family. Like right now all the points belong to this family. So every solutions of this equation will definitely lie here. It's so disciplined child, right? It cannot be inside, it can't go outside. So all these solutions, the bundles or the box of solutions that you'll make out of it, it will lie on the circle. Okay, so this is the fundamental idea behind locus. So in locus, basically what we do, there will be a fixed geometrical condition or conditions, and a particle is allowed to follow that rule of the game. So you have guardianship. Sometimes dad keeps you saying something, and then extra guardianship by your mom, maybe by your elder brother. So there are so many guardianships on the point, and based on that, the point behaves in a certain way. You start behaving in a certain way. So that kind of guardianship has to be loaded on the head of that point. And then we allow the point to move on a plane or maybe in a space. And the location stressed by that point is known as locus. So I hope the basic crux, the heart and soul of the concept is quite clear to you. Now mathematically it's quite simple, because you will use section formula or distance formula, or maybe slope of two lines equals -1. So we have section formula, a point dividing it into some ratio, maybe 2:1 or 3:2, whatever. You have another instrument of solving locus problem is distance formula, so Mr. Python here, which is x2 minus x1 whole square plus y2 minus y1 whole square. Then we have one more tool, which is basically angle between two lines, Okay, so tan theta is given as m1 minus m2 by 1 plus m1 m2 if the slope of one line is m1 and m2. And of course, if you want this theta to be acute, we have to take mod. And then the special consequence, what if theta becomes 90? If theta becomes 90, tan 90 is a tight slap on you, so denominator has to become 0 to slap you, to greet you. Sometimes being slapped, you feel nice, because tan 90 is not defined, hence the denominator has to die, and that will give m1 m2 minus 1. So this is very powerful thing. If you have two perpendicular line, okay, perpendicular line, the product of slope is always -1. And that's crazy. You can feel like if you have a line with 45 degree and the line with 135 degree, the slope is 1, 10 of 135. Yeah, exactly. Now some of you might ask the question, sir, what the slope of x-axis and y-axis? So x-axis slope is 0, y-axis slope is infinite. In fact, you can call plus minus infinity. So now it's, so 0 into infinity is -1. And does it make sense? Yeah, it makes sense, because infinity we can write 1 by tending to 0, right? So kind of 0 by 0 can be anything. Okay, because philosophically out of nothing you are trying to get something. So if 0 by 0 can be anything, it can take a value of -1. So like m1 m2 -1 bridges the gap even for the x and y axis. Anyway, that was fun doing this. What I'll do right now is I will show you some animation to inculcate more interest, and we'll solve some problem based on that animation. Okay, so let's start doing that. So here is the first animation, which is of great practical purpose in the industrial application, and that is known as kinematical mechanism. Let's start with one of the animations. And here we go. So this is the most beautiful animation I've come across. As you can clearly see, we have a fixed circle and another circle, another chotu circle. This smaller guy is rolling over that bigger circle internally. Okay, all of you can see this. And what a crazy thing. Suppose if you pick up any point, let's talk of a red guy on the smaller circle. Okay, a red point, a red dot on the smaller circle. Okay, so it's so nonsensical that how that red dot is going in a straight line, although the circle is rolling inside another circle. So you see such a straight connection of a straight line with these two circles. So these two circles are interacting and you are getting a straight line as a consequences. So how you actually put this in the language of locus or language of location? A language of locus is just a fanciful mathematical way of expressing your feeling, right? So it's like if I have got a smaller circle which is rolling over the other circle. Okay, of course you see the velocity of roll is basically constant over here in this picture. So if we have a smaller circle which is rolling over the larger circle inside here internally, so that is always tangent to that. Rolling means is always tangent to the smaller circle. Then the locus of any point on the periphery is a straight line. Such a crazy answer. So whether it's red guy or black one or purple one, everyone is following a straight line. Everyone is following a straight line, right? And vice versa, you can tell. What's more enchanting is you see all those red dots or purple dots or black dots, blue or green. Okay, all these dots are just moving on a line. Can you see? All these dots are just moving on a line. The only thing is some of them are latecomer and some of them are earlycomer. Okay, so in the terms of physics, we call it they have phase lag. Like they're not starting from the same point. Okay, so phase lag is basically I'm coming late to school by 10 minutes and you are on time. Okay, so we are having a phase lag of 10 minutes. Okay, so we are not starting at the same instant. So you see, if all of them are having a constant phase lag, okay, and all of us, let's say Golu, Bolu, Bikki, Rikki, Pikki, okay, Golu, Bolu, Bikki, Rikki, Pikki, अगर ये straight line पे move कर रहा है, ये constant, like velocity से, तो आप clearly देख सकते हो, it feels as if a circle is created, and that's just an illusion, because the reality is there is no circle at all. All these guys are just moving in a straight line, and what you are seeing a circle. So this is a wonderful application of locus. Right? It means if I let all these particles move on a line and imagine a circle connecting all of them, so that circle keeps on moving, it feels as if it's rolling on the other bigger circle. Okay, so I hope you have enjoyed this. We can take one of the very smaller case of this, and you can create a locus problem mathematically. So the question can be like this, like you have a larger circle centered at origin having radius, let's say 4 units. You have got a smaller circle, okay, which is rolling inside it, and take a point on the periphery. So when it's rolling, what's the locus of that point on the periphery? So clearly it will be a straight line here. Okay, so I hope like you enjoyed this and you motivated this. Let's move to the second animation now. So what I'll do today is we'll take some of this animation and we'll solve it mathematically. How mathematics will I speak on behalf of this beautiful picture. One of the beautiful animation just by, this is known as Chebyshev linkage. So those who are in mechanical engineering are acquainted with this. So hopefully like some of you will become a good mechanical engineer. Anyway, so let's start with this. So you can clearly see it's quite a simple connection of rods. Okay, so we have two rods, which is represented mathematically as a straight line, which are hinged to two fixed points, and we have third rod connected to the other ends. And the point is, what is the locus of the midpoint of those, right? So basically, you can tell like the first rod is given some velocity, okay, and that in a way turns the other rod, and that again pulls back the third one. So the locus of midpoint is this nice beautiful curve. Okay, it looks like ellipse, but it's not ellipse. So some kind of curve we are getting. Okay, so it's like looking like Ardh Chandrama kind of thing. Anyway, okay, so this is still a motivation of how, because until you operate this picture, okay, let's say either you have to create this mechanism physically, or you have to write a lot of code to create this animation. But if you have a mathematician, he'll just write some equations, and that equations will give you the equation of that curve, okay, like the midpoint here, and that you can simply draw using calculus, mechanically with your hand. So without actually doing the experiment, without actually animating it or creating any physical model, you can tell for surety what exactly will be the curve in which midpoint is moving. And that's what the beauty of mathematics. Okay, so before I show you the next animation, let's get a feel of what exactly the question is. So we'll do animation for two more questions, and both questions will be solved using the mathematical equations. What I mean is, now numbers will speak on behalf of this picture. So we'll see like there are now no pictures. Imagine we don't live in a world where I can see even. So how those dead numbers will speak on behalf of those, you know, like pics and those movements, how this algebra has that hidden information in it. So one of the situation is we have a parabola, fixed parabola, and now you have another variable parabola which rolls on this fixed parabola, right? Okay, so you see as it's rolling as this parabola, so we have a fixed parabola, and now you have variable parabola which starts its journey from the vertex, and now it's start rolling it. So if when it will roll, it will do like this, right? And further it will go like this. So you can clearly see like there is a, you know, locus to the vertex, right? Similarly, the parabola when it rolls here, maybe it goes like this, and then further it goes something like this. So there is a locus to the vertex in which is moving. What is the locus of vertex? So clearly we can see vertex seems to follow some of the curve. So we are interested in the locus of the vertex of a moving parabola on a fixed parabola as it rolls without slipping. So we have very nice animation in front of you. So we have a blue parabola which is fixed. We have got a black one which is moving without slipping on the fixed parabola, and the locus of vertex is clearly, as we guessed, you can see it's a nice beautiful red curve. Can algebra speak on behalf of this nice picture? The answer is of course yes. So you take a random point, a vertex as x comma y, and try to solve this and see if you can get to the equation. That's one of the beautiful challenges that I'm giving to you. Let's move to our second situation, and our second situation goes like this. So we have an ellipse, okay. As all of you know, ellipse is characterized by its length of major axis and minor axis, because there is something called length of major axis which is 2a, length of minor axis is 2b. So this is basically shape factor, like a and b decides basically shape and size of ellipse, right? So there is a term called eccentricity which you must be knowing. Eccentricity a square is 1 minus b a square by a square. So the ratio of b by a is basically an indication of slap factor. I call it basically slap factor. कि आप कितने जोर से you have slapped a circle to get ellipse. So let's say if I start slapping circle this way, I'll get ellipse like this. If you slap circle, okay, this way you'll get vertical ellipse. If you slap sidewise, anyway, cool. So that slap factor captures the feeling of eccentricity, like how much it is off track from the circle, eccentric behavior. Anyway, so now the question goes like this. We have a like ellipse with length of major and minor axis as and 2b, which means semi major is A and semi minor is B. So that completely fix up the size in ellipse. Now this ellipse is sliding. This ellipse is sliding, so of course it will have focus, two focus, S1, S2 and some center, right? As the ellipse slides, so maybe in one of the situation ellipse might do this. We can have a, so as the ellipse is sliding, the center will change, right? New center, maybe new center. So center will have some locus. Center will move along some curve, and so is the focus, right? So focus will have some locus. So the question is locus of focus. As this configuration will have different orientation, but the guardianship is the ellipse in any configuration, it always touches both coordinate axes. Yes, the ellipse in any configuration will touches both coordinate axes. So if we'll take the snapshot of these pictures, there will be many locations for center. You have to find, first question, locus of focus, many locations from S1. Because S1 focus, S1 locus and S2 locus will be similar in nature, right? And then locus of center. So pause the video and give a try. So in today's lecture, I am not writing any mathematical equations. That will be done in the next lectures using some of the questions, and that will give you an insight to how exactly you do this. Since I have taken complicated problems, which feels very nice to see and visualize, it's very soothing for your eyes, but it takes a little bit, command over algebra to do it. Anyway, you will enjoy this lecture subsequently. So let's see the animation of how exactly S1 and C can go. I think like before we go further, you can give a guess for the locus of center of this ellipse. What do you feel? Okay, yeah, it will be arc, because if the ellipse is in first quadrant, you'll get an arc, not the full curve. Oh wow, some of you are feeling like a parabola, some is telling some a part of circle. Okay, great. Anyone who feels like a straight line? No, because it will bend. Yeah, it's correct. So definitely it's not a straight line. It will be maybe part of circle, parabola. Okay, who knows? Maybe hyperbola? No. Oh, it cannot be hyperbola. Great. Why? Because if the ellipse starts floating on all the four axes separately, let's say if you take situation where ellipse is here, right? Or here and here, then definitely they must come with a closed curve, right? So it may be some kind of ellipse or circle or some random thing. So we are not sure, not completely sure about. Okay, what about S1? Well, they're also telling like either this or this. Do you feel S1 will follow circle? Okay. So some of you are like, no, S1 cannot follow circle because it's not moving so nicely, because it was center was at the center of the ellipse, so its path was more good. It's kind of center of mass path. Because you can relate with this. Let's say if I have a rod of length L and you throw it in air, so it will attain some different configuration while going, right? Like before it falls down, maybe. Okay, so if we will join the center will follow a very nice path. It's basically parabola, as you know, parabolic path. But the other point is going in a crazy way, right? Other point has some crazy locus path. So in that sense, yeah, S1 we expect like some kind of crazy curve if in all the four quadrant it moves. So again, so you are quite close to the actual answer. In fact, let's see the animation, and then in the next lecture I'll give you exact mathematical equations to find this answer for the locus question. As your expectation was correct, you can clearly see the ellipse moves on a circular arc, the center of the ellipse as the, okay. So here is the answer for your beautiful question. As you can clearly see, as the ellipse, you can imagine as if it were an egg, two-dimensional egg, which is sliding over two walls. The center is moving on a circular arc. And see, the focus is going on some crazy curve, because both focus has to move on a certain curve, okay? And both focus is lying on the same curve. It also looks like a nice egg is used, okay, kind of. And if this ellipse is free to move along all the four quadrant, then we'll have these four nice curves for the focus, which are disjoint clearly, and even some disjoint arc like NM. We'll have N dash, M dash, N double dash, M double dash, and triple dash, M triple dash. So we have four different arcs for the circle. Okay, so in next class we'll try to write the equation of the circle, and we'll see how to write the equation of the locus of focus also. Okay, you give a try. I'm just giving you a hint. There is a very interesting property for ellipse. The image of focus on any tangent will lie on a circle with center as other focus and radius as 2a. This you can prove either from the coordinate setup, or you can give a beautiful geometrical explanation. So in next lecture, I'll give you a geometrical proof of this, and then we'll write coordinate geometry ideas to exactly find